My name is Bill Shin. I'm a Principal Security Solution Architect with Amazon Web Services. This is the second time I presented in Chicago. Did anybody attend this talk last year at the Chicago Summit? Nice, so fresh audience. Thank you very much for coming. Security is critically important, and as a solution architect, I get to spend my time working with enterprise customers, large financial institutions, our global accounts and our enterprise accounts, helping them really adopt AWS kind of end to end. And really the primary question that I get asked as a security solution architect is, where do I start? What's the prescriptive approach that I should be taking as an enterprise or a large company to think about moving to the cloud? So this will apply whether you're a small company, a startup, an individual developer, or the biggest companies in the world. Over the last couple of years, we've really noticed a very prescriptive approach that has kind of evolved. And again, this is an introductory talk. So it'll get somewhat technical, and I'll do some demos kind of throughout and mostly at the end. But the idea is that you walk away from this talk with a plan, right? You can go back to work, and you can evangelize the plan internally. You can do it yourself. You can work with all the other teams in your organization, and you'll know who to get on board, where to start, and have an estimate and some idea of what it's going to take to have control and visibility and auditability and all the things that are important to managing risk and managing compliance and privacy and security as you move your workloads and your business to AWS. So the first thing we want everyone to feel comfortable with is using AWS as a cloud provider. So trusting us and understanding what we do under the hood, we'll briefly cover, to give you a comfort and transparency and the ability to make your stakeholders upstream confident that when you move your critical business information and personal information that you're storing to AWS, that you can meet regulatory compliance objectives, that you can meet your privacy objectives, and you can be secure. We'll talk about building a strong compliance foundation. So in addition to the controls and things that you've already got in your enterprise or in your business, and how you demonstrate to your auditors, your regulators, your board, your shareholders, your customers, that you're compliant with various legal regimes or regulatory requirements, we'll show how you can inherit controls from AWS to do that as kind of the second step. And it's really a progression. This is you can switch some of these things around a little bit, but for the most part, we see customers adopting in this pattern. Integrating identity and access management is generally the first technical step you'll take. You really can't do anything on AWS without authentication and authorization, and most companies have invested a significant amount of resources in managing identity and workforce lifecycle management. So we'll make sure that that's kind of one of the first principles. We'll talk about detective controls, because before you even start launching instances or start storing data, we want to make sure that you have absolute visibility into what's happening. So you have authorization and you have visibility before you spend a dime, really. And before you start moving things and taking steps to move that data into the cloud, we want to make sure that you know what's going on and have a plan to monitor and manage and get alerts for things that are critical for security. We'll talk a little bit about network segmentation. There are several other talks today that I'll refer to throughout this throughout this introductory talk that are happening later in the day. There's some sessions on access control and network segmentation. There's another session on data protection, which covers cryptographic services like key management service more in depth than I'll touch on in this talk, but we'll briefly talk about it as part of the overall plan. We'll talk about optimizing change control, and whether you have monthly or quarterly releases or daily change reviews or stand-ups or scrums or sprints, or however you manage the change and the implementation of code changes and product changes and infrastructure changes today, it's critically important that you are able to leverage the features and services of AWS to maintain that control you have through your existing change management practices. Even if you're a developer and you can just make changes whenever you want, that should still be an orchestrated plan. And I think the services that we have offered and some of the things we've introduced recently around change management will really help you get more control and more security around what's happening to the AWS environment. And lastly, we'll talk about automating security functions. Critically important, we definitely see a progression. So some of these things might be manual at first when you're experimenting, when you're learning, when you're getting comfortable with AWS. But as you move, and pretty quickly, as you move through this prescriptive approach, you'll start automating a lot of these functions. So while automation is kind of at the end here, because it makes sense when you're learning to kind of do things manually maybe the first time, at any scale at all, it starts to make sense to automate some of these things. And it's really one of the differentiating aspects of AWS is that you're able to automate almost every single thing you can do or would need to do in this prescriptive plan. So everything's an API call, remember that. And we'll show some examples of pretty common security use cases as part of a small demonstration. So first, let's understand what we do under the hood and what we do that you don't see that's critically important for you to gain trust and confidence when you move your data to AWS. So last year, we talked about kind of the 5 whys of why enterprise security is traditionally very hard. And I'll summarize that this year by just saying that it's really the lack of visibility and the low degree of automation that makes security very difficult in most companies. Very few security analysts and auditors and compliance folks wake up and say, let's do that audit again, right? That was super fun. Let's go do it again. If you can, the other thing is there's so much control, right? There's so many checks and balances and process and procedure because you have humans who have to make sure that changes occur according to plan. Right? If you're making a manual change, or if you have handoffs between teams, you have to make sure that those things go according to plan. And that means manual reviews and manual steps, and it makes it not conducive in most infrastructure environments and traditional data center environments to automation. Just the way the tools are built, the fact that you have to actually rack and stack servers or connect things to patch panels or provision storage, all those things take manual steps. And in the cloud, they don't. And so you're able to automate those things, which means that you can benefit from things like ubiquitous logging in all the services to get more visibility into the changes that are happening through automation. And it's kind of a feedback loop. So the more things you automate, the more visibility you get, which means that security gets easier. There's less manual changes, and it can be faster. So Matt talked about this a little bit in the keynote. Really, our philosophy is our internal approach, and certainly the one we put to customers, is that you can move fast and stay secure. And in traditional environments, security oftentimes isn't the fastest part of the organization, right? You have to manage risk and you have to manage things carefully, so it tends to be somewhat of a gating factor for many of the stage gates in an SDLC or a release or a big infrastructure change because it has to be done perfectly every time. So really the philosophy is that choosing security does not mean giving up on convenience or introducing complexity. We think that you can have both in AWS, and it's a principle that we follow every day when we operate the services that you're consuming. The other thing is security has to be the fastest thing in the organization, right? It has to be first, and it has to be fast, because you have to respond to a changing landscape, both a threat landscape and a regulatory landscape. The way that the developers and engineers are releasing products and code today, you can launch businesses in weeks or months as opposed to quarters and years now. And so what that means is there's constantly application security or application changes happening from DevOps or from engineering or from the developer organizations that security has to be able to accommodate. And if security is traditionally dealing with things like infrastructure vulnerability management and CVEs and patching and identity management and logging and scaling the logging functions of the security group, that means they're not spending as much time on application security, which is really the fastest part of moving the business forward to increase the top line, essentially. So security has to be fast with those traditional functions in order to best respond to the way that the business is growing all the time. And given the capabilities that developers have now today to just create and innovate, security really needs to move up the stack and be able to focus on data and application security and code quality more than it has in the past. So really we're trying to take those undifferentiated portions of what security is doing most of the time in most organizations and really free those resources up to focus on security analytics and threat intelligence and data analysis like event logging, like actually analyze the events, not just try to deal with scaling your logging solutions to eat them, right? You want to be able to be security analysts again. You want to be able to partner and peer up with developers. So making you fast as security practitioners and enabling the folks in the room who are maybe devs or engineers or IT managers to really go empower their security organization to be a partner is a critical part of what we're trying to do. And we do that internally every day. It's security ownership is a part of the DNA of Amazon Web Services. Every service team has an application security engineer and reviewer process they have to go through for service launches, major feature announcements, anything that deals with customer content, anything that deals with cryptography or authentication authorization. It's ingrained in the way that all of our developers manage security. So yes, we have a central application security engineering team. We have a CISO, Steve Schmidt, who has a decent-sized organization, but the scale at which Amazon Web Services operates means they can't be everywhere at once. They have to empower other teams to take accountability and responsibility for security themselves, which means creating centralized tools, centralized processes, and enablers for those dev teams and engineering and service teams to go out and create the great services that you're able to use. But it also means that for those folks that we're launching services every day, and features all the time, they have to be able to move quickly, but they have to be secure because customer content and the security of your workloads is paramount. It's job zero for us. So it means that it has to be part of every service team person's DNA, essentially. It means that everyone's an owner, right? I do this survey of like, raise your hand if you're like a security person, like if you're, it's pretty good. It's a trick question, though, because it's everyone's responsibility, right? So you have to take it, every person who's using AWS, whether you're a sysadmin or a server engineer or a developer, it has to be part of your DNA, too. And it means that you can have that autonomy to move quickly if you're accounting for security in the way you do your work. It also means that it enables easier and smoother communication. So it's at the executive level at AWS where security is discussed every single week. Andy gets a briefing with Steve and the security team and the compliance and security assurance teams every single week. It's an executive function, and it's part of everything we do. It means that it's embedded in all of our business. So you're able to strengthen your security posture. One of the things we invest heavily in is industry certifications, and we'll talk about that a little bit in our security assurance program as well. We have over 30 global compliance certifications, security assurance programs, and accreditations, which means that no matter where you go in the world, as you grow globally, you're able to meet the regulatory compliance and privacy directives of pretty much anywhere you're operating. We aggressively seek these out, both at the request of our customers and to get ahead of where we think our customers are going to be. We know it's pretty much table stakes to operate on personal information, like health information or financial services information, anywhere in the world where customers want to use our services. So we're trying to get ahead of that, and we have a really strong track record over the last 10 years of being the first cloud provider to get many of these certifications. Moving to the right. Yeah, you're right. Security infrastructure is built to scale to the needs of the military, to financial institutions and global banks, and to highly sensitive organizations. If you see the references that were presented in the keynote today, folks like GE and Capital One and others, Philips that are moving 18 petabytes of medical information to AWS. We've gone through the due diligence of all these organizations, right? They're comfortable, and they're following this prescriptive approach to adopting AWS. One of the things is that, we have a lot of scale. We have, regions around the world, and we have customers in 190 countries and every imaginable vertical, which means we get feedback from every part of different industries. So, what's important to financial services may be slightly different than what's important to healthcare, but we're able to innovate for both verticals and feed that back into every customer. So whether you're a developer, an individual developer, a startup, or a small business, you're benefiting from using the services that are built to meet the needs of the military, of government organizations, of large enterprises that are highly regulated. We launched over 700 features last year, services and features. A pretty significant portion of those, if you go back through the service launch history, were related to making security and management of security easier. So we're learning from all of our customers, and when we launch things like Inspector, and we launch things like CloudFormation change sets, or we launch things like identity and access management, managed policies that we launched last year, all those are the direct request of our many customers, and so you're able to leverage those enhancements in that fast feature flow. So most CISOs have like an 18-month to 3-year roadmap, and they've got long tail projects that are capital intensive and take a long time to implement and require a lot of coordination across big enterprises. When we launch services, you're able to use them at very low cost almost immediately. That native functionality and the tools that come with the platform, you'll notice we don't really charge a lot for security features. We think it's important that you be able to benefit from those. You really don't pay for things unless you're computing something sending packets somewhere or storing bits somewhere. Most of the security functionality, like templatizing your infrastructure, for example, to build your network topology and build out your network segmentation, you can do that in a text file. You don't need to buy millions and millions of dollars of hardware to put in a data center. You can experiment with that network topology before you ever even execute it or route a packet through it. Most importantly, security is a shared responsibility. Right? There's a lot under the hood that we do to scale the services, to do data center security and physical security, the application security of our APIs, and the security training for our staff and the background checks that we perform. All those are captured in the compliance and security assurance programs. I'll talk about it in a sec. But really, that responsibility of the cloud is ours. But as you move into the AWS environment, it's really, really important as a first principle, and that's why we put this first in the prescriptive approach, is that you understand what your responsibilities are, right? The fact that you have a lot of control also means you have a lot of responsibility. You have that flexibility and that agility, but with that comes understanding the roles and responsibilities for each control that you find important. So remember, we don't access your operating systems. We don't patch your operating systems. We're not logging into your databases to perform schema validation or backup and recovery of those databases. There are services and there are plenty of features that make that easy, but it's your responsibility, similar to the way you've already invested in these controls today. And what we usually start with when we engage with large customers is talking about their control framework. Right? It may be based on PCI, it may be based on ISO 27001, or maybe it's a shuffle of a bunch of different controls that they found best fit their business. But we really want to early on understand that control framework and where those responsibilities and roles and accountabilities lie in the organization. Because we're not going to reinvent that every single time. There's no reason to do that. The compliance functions, the audit functions, all rely on that design of the control framework and a roles and responsibilities matrix put together so that the organization understands who's accountable. And we're not going to break that, right? I mean, you come into the AWS environment knowing that you've got a control framework you're comfortable with as a company or an organization, and you're going to put that onto the cloud. But it still means that you have responsibility pretty much up the stack. If you're using things like EC2 for infrastructure as a service, or even if you're using more managed services like DynamoDB for managed NoSQL, yes, you have an API and we manage the backend, but you still have identity and access management and authorization to your tables. You still have logging, and you still have the integrity of your data from a validation perspective and completeness perspective. You can set up streams, you can replicate that content, you can back up that content using our features, but it's your responsibility to enable those features that we make available. That's one of the ways we best work with customers, is to make sure that you know what those responsibilities are and that you have a path forward to make sure that whoever owns that control can execute on it effectively. Before we move on to sort of the next steps, understand that there's more training available, right? There's a 3-hour free online class that's it's 3 hours, security fundamentals, which will go into more detail about the things we're talking about in the sessions today. There's also a 3-day class on security operations. So if you're in a security role and you're looking to help enable your business to use the cloud, that 3-day class is important. So you'll work directly with AWS trainers to understand a little bit more about what we do internally around the shared responsibility model and our controls under the hood, but you'll also learn very high-scale operation practices for security. So building strong compliance foundations means understanding our assurance programs. So things like a SOC 1 Type 2 and a SOC 2 Type 2. These are really rigorous, thorough audits performed by usually E&Y or whatever auditor we are using for a different framework. So PCI or FedRAMP use different auditors. But if you're familiar with these audits, they're quite rigorous. We make these reports available to customers. And the important part here is that you inherit these controls. Right? For the things that are tested by our auditors, you're able to map those directly into your compliance and control frameworks that you already have, which means cost reduction primarily, right? If you run a security assurance or audit program and you don't have to worry about a significant portion of the controls that you're now responsible for because you're putting that in our portion of responsibility, it means you can focus on the ones that are a little further up the stack, a little higher order, a little closer to the data, and you're able to move more quickly as a security organization. If you go to aws.amazon.com/compliance or /security, you'll find a whole bunch of information about our global security assurance programs around the world. So as you build that strong governance and compliance foundation, there's kind of 3 things that are important, right? Account ownership. There's a lot of times where I go into a customer account and I say, how many AWS accounts do you have? And this, by AWS account, I mean a 12-digit account ID that establishes the relationship between you and us, right? Every account is a unique authorization or an authentication boundary. and it creates a new account every time you sign up, basically, for AWS. So that root account, or that AWS account, if I walk into an organization and say, how many do you have? That number should always be accurate, right? If you think you have 4 accounts, but you have 8, it means that you're unaware as a security organization about the footprint of those other accounts, right? So it's really important to work with AWS and work with us to make sure you know about all the accounts that your organization has, so then you know about the scope and the footprint that you have to manage. The contact information is absolutely critical. There's 3 kinds of contact information: the admin, the billing, and the security contact. It's really, really important that when you go home and when you leave the summit, you go make sure that all the accounts that you know about have up-to-date security contact information. So in terms of us notifying you or being able to get in touch with you about important security-related things that are proactive, it's very important that we have that relationship and that contact information identified. Lastly, there's a whole bunch of folks like me waiting to help, right? And don't struggle through this stuff. If you think there's a learning curve to any of this, you have an army of people waiting to help you. There's your sales and account representatives. If you don't know who they are, you have one. You can reach out through the contacts on the website and find who your sales representative is. They're vital in helping you understand and positioning the services. There's a deep solution architecture function in AWS, as well as support and technical account managers and even customer success managers that we have for enterprise accounts. Professional services and consulting partners make up a broad range of people who can help you accelerate adoption and accelerate this prescriptive plan for security as you move to the cloud. Trusted Advisor is also great for establishing that compliance foundation, right? So the Trusted Advisor dashboard provides checks for things like billing, for things like performance and optimization and fault tolerance, and most of all, security, right? There's quite a lot of checks in there for things like enabling CloudTrail, making sure you're rotating your access keys, making sure your buckets are secure, making sure you have good, sensible defaults for security or security groups or firewall rules, and they'll advise you, and you can look at reports and use those to sort of start the process of being compliant with our best practices and following them, as well as implementing controls in your own organization. So kind of the first technical piece really is identity and access management, right? So as you move to AWS, you want to make sure that you set the right foundation for access. So really I'm talking about the whole workforce lifecycle management. So contractors, employees, temporary access, partners and consultants that may be working in your account. Most people have some kind of on-premises directory, whether it's Active Directory or LDAP or something cloud-based. There's a place where HR typically puts user entities, and from there you draw all of the entitlements and the capabilities that people have in the company. It's a very significant investment and absolutely critical to maintaining the right access. So many of the regulatory requirements relate to access to data and separation of duties and those kind of things. So knowing what entitlements people have is kind of a first principle of using the cloud. And you've already invested in this heavily, right? When I talk about identity access management, who's seen the IAM console? That's a good group of folks. So cool. So I won't spend a lot of time on that, but for the folks who haven't, I want to give you a quick sense of what that looks like. So when I talk about users, groups, and roles, right, what that translates to in the console is users, right? There's just a user entity. I was kind of into admin when I started creating users, I guess. So you can have users, right? If you don't have a managed directory or something like that on premises, and there's definitely use cases to having IAM users, but for the most part, you want to be using roles, right? You can create users on the cloud, but unless you have a really tight provisioning process, when you onboard and offboard a staff member, you want to make sure there's something that triggers a deprovisioning or provisioning or deprovisioning, or at least a review of the access of any particular user. This is a separate authentication store, so users in IAM are not necessarily connected into your on-premises directory. You do that through SAML federation and roles. When I talk about groups, it's just a way to apply policy to a set of users. So you put users in groups just like any sort of directory, and you apply policy at that level. And roles are really for managing access to applications as well as for federation. So we'll talk a little bit more about that in a sec. So the combination of these things, right, users, groups, roles, and permissions, make up kind of the IAM ecosystem. And you're able to create all sorts of combinations of policies that have things like actions and conditions and statements that can create a very flexible model. There's another talk this afternoon by Andrew Kiggins, who will be talking a little bit more about the access policy language and things like that. So if you're already editing JSON policies, obviously this is just an introductory talk, but the point is that those policies are extremely flexible, and now they're a first-class object as well. So not just users, groups, and roles where you attached inline policies, now you actually have managed policies that exist as a first-class object. So kind of walk through this with most customers. Account governance for new accounts, whether you've got 150 or 2,000 or 10,000 AWS accounts, for whatever 10,001 account, you should be doing these things for every single AWS account that you have. Really the root account, which is that 12-digit number that you sign up for the account with, that needs to have multi-factor authentication and probably split access among two different teams of people. So I talk about set A and set B of people and being able to segregate the pairs of people who can actually manage that root account. You don't use that root account from day to day in operations or production or even development. There's no need for it other than establishing the relationship with AWS. And you have to have a root of trust from an authentication perspective somewhere, so that root account is there to establish the account. But then you put a multi-factor authentication token on it and then split access to who has the password and username to the account and who has the multi-factor authentication token. Especially for critical production workloads, you really want to separate access to that root account. You want to map in your enterprise roles. So if you've invested heavily in role management and creating Active Directory groups or LDAP groups that represent functions and functional tasks and capabilities within the company, you want to map those into AWS by creating roles. And for the most part, the AWS roles that come out of the box, the managed roles by AWS, represent read-only and power user and full admin kind of roles for each one of the services. And you can map those into existing roles for database administrators, network administrators, security operations. For anybody who's really managing the infrastructure and the assets in the cloud, you'll want to map in those enterprise roles. And just have a relationship so you know that if someone's in an existing group, that you'll probably have a role for them to use, like server admins or storage and backup admins. Federation is a great first principle. So if you have an identity provider or IDP on premises, things like Active Directory Federation Services or Okta or Ping, SiteMinder, all of those work really well with federation via SAML 2.0 into the AWS Management Console, and even now there's hooks into the CLI tools as well, so you can have roles that you assume through federation, depending on your IDP and how it works. If it has an API, or even if it doesn't in some cases, you can still use the CLI and even the SDKs in some cases to get, you trade a SAML assertion essentially for a temporary access token on the AWS side, and you're able to kind of SAML your way into the console. So you go to your identity provider internally facing web console where you do single sign-on, and it redirects you if properly architected into the management console. And once you're there, you can switch roles, or you can go back to your IDP and log in again and choose a different role to assume when you go into the console. Basically allows you to leverage those existing enterprise groups once you've mapped them and be able to seamlessly go from managed workforce where you've got your HR system feeding your directory so that you have movers and leavers or add, move, change activity of the workforce. As that happens and it updates your directory and you terminate people's access when they leave the company or you review it when they no longer sit in the same role, you're able to integrate that and leverage it as they use AWS with almost no work. I mean, it really doesn't require a whole lot. Federation is kind of one of those things that doesn't take too long to set up. I also recommend that InfoSec has their own account, right, for a bunch of reasons. One is experimentation. We notice a high correlation between companies where information security has their own AWS account and the speed and the comfort and the agility that they get for the other teams using AWS. When security is at the table, everybody else tends to move pretty quickly. And giving InfoSec cross-account role access, so there's this notion of cross-account roles where if I have an AWS account and you have an AWS account, you can grant me the capability to assume a role in your account, and you can constrain what I can do in that account. So if you have 12 DevOps teams that are all cooking out applications all the time, and security wants to know what's going on, so vulnerability management, forensics, asset management, identity management, all the things security owns and is somewhat responsible for at least from making sure it's happening, giving them a cross-account role into the actual application accounts or production accounts that are being used, gives them that flexibility to move quickly. You can give them read-only access or give them access to do security group management or manage DNS changes in Route 53 or do backups or even stand up a forensic capability in the event of an incident of some kind. But getting that cross-account role set up early on and getting security at the table tends to be a critical success factor in adoption. And lastly, actions and conditions. We see over and over again people kind of using sort of excessive permissions, right? And there's tools in IAM called Access Advisor that we launched last year. That's fantastic for reviewing what you're actually using. So if you think you have overly permissive IAM policies that are attached to users, groups, and roles, you can use Access Advisor to kind of help model revision and remediation of the actions that people are allowed to take. So remember, everything you do on AWS is an API call. Whether you're using the console, the CLI tools, or the SDKs, you're always hitting an API, which means that everything you do is basically a method call. So attaching storage, changing a security group, launching a CloudFormation template, creating a user, putting policy, all those are individual API calls. So IAM, or Identity Access Management, has quite a few API calls. Put user policy, put group policy, put role policy. Each one of those can be instrumented as an individual permission. So you can get very, very fine-grained with the actions that you allow users, groups, and roles to take. You don't have to. You can be kind of broad in the roles. But it's important that you understand and have a capability to see what actions and entitlements you have out there on your principles. The other thing is conditions. So you can heavily limit where people can come from source IPs. You can limit time of day. You can have step-up authentication, where for critical API calls, where you say delete VPC, right, or disable CloudTrail, or put role policy or attach role policy. Those are really security sensitive or high-risk sort of activities around deleting data or changing the infrastructure in a material way. All those can be instrumented with conditions on those specific API calls, right? And so you can have, in day-to-day, people can do read-only activities or small, lower-risk changes without MFA. But if you want them to do something that requires a change approval or something, you can even split the access between the person who can make who can sign in and make the request and then the person who has the MFA. So they have to have dual authentication. So all those conditions are possible for pretty much. There's a base set of conditions that are available for all services, and then there's also resource-based permissions as well that you can apply to certain services. So I consider those baseline requirements. Those are day one requirements for a new account. So if you don't have those things set up on your existing accounts, I think it's worth a look. It's worth a work stream in your organization to go and figure out what's important and sort of prioritize that work a little bit. Trusted Advisor can help with some of this stuff, but being able to just have a basic report or some capability to know whether these things are in place, I think is a good building block. So now that you have identity and access set up and people can kind of do the work they need to do, rather than just take the reins off and let everybody go to town, you want to make sure you have detective capability set up as well, right? So we have really two services that kind of work pretty well together to give you a baseline of detective control and visibility that you'd expect in your own enterprise. So most of the time today in traditional enterprises, this is done with syslog and Windows Event Log and things like Security Information Event Management Systems or SIMs, traditional ones from ArcSight and others. Who has a SIM on-prem or uses Splunk or some sort of like log management, log search utility? Pretty much most big companies do. CloudTrail provides a very detailed log of every single API call you make. This will be covered a little bit more in depth in another talk, but essentially, I'll give you a quick example. Whenever you make an API call, so this is me signing into the console. Can everybody see this? Raise your hand in the back if you can see it. Good, okay. All the 2020 folks in the back. So essentially, you see the log messages of me signing into the console, of Lambda creating a log stream for me on my behalf from some app I wrote, of these instances doing something. There's an instance that I'll demonstrate later that's actually taking action on my behalf. So all these log messages are here, but the fidelity of this is pretty insane. So it shows you not only the actual event ID, but the source, the actual references and resources that were referred to, but you get this fine-grained view of all the API calls. So when I launch an instance, for example, so if someone, say, starts up a server or launches a server, you're seeing all the request parameters and response parameters to every API call that you make. So and think about this, this is across the entire infrastructure stack. So everything from DNS management in Route 53 to object storage in S3 and the bucket policies and buckets that you set up for S3 to launching load balancers, launching servers, allocating EBS volumes. Everything you normally do in a traditional environment would have a different log format and require another integration into your log search platform or your SIEM. This is one format, one JSON format of a log file that gives you the full fidelity of every activity that's happening, which is a very powerful thing for security practitioners. So again, this is launching an instance. You can see the session, you can see the actual the caller, the event time, all the request parameters that I made. So I wanted an AMI, I wanted one of them, I wanted this particular instance size, with the region I'm launching it in and the availability zone, all the subnets and the VPCs I'm launching it into, as well as the response parameters too. So just understand that that fidelity is there. You have to enable this though, right? So the key thing to remember is that you should enable it globally for all regions. So even if you just use US West 2 like Oregon or Northern Virginia or something like that, your account has access to launch instances in Singapore and Sao Paulo and Sydney and Tokyo. And so enabling CloudTrail globally and centralizing all those logs back into one place is an absolute first principle and step you should take before you start moving major production workloads. So we made it super, super easy late last year by setting a home region, and it future-proofs you against future launches of new regions by AWS too. So when we launched the Korea region, for example, you would have been able to incorporate that region immediately using that home region feature. So you can set your home region to be one that's local to you so that there's less latency to get the logs once they're there. But basically, we'll take all the data from all the regions and consolidate that globally into one region for you, including all new future regions that we launch. So that feature has been available since late last year. Most big enterprises that have significant existing investments in things like log search platforms and analytics platforms or SIEM tools, they ultimately put some portion of the CloudTrail logs they roll it up into that stack because their security operations team, their SOC, their MSSP, their audit functions and compliance functions are kind of eating off that SIEM platform or that top-level manager where all the logs go. There's several ways to get CloudTrail logs into those platforms, whether it's through S3 buckets and then you pull them from the S3 bucket and parse them, or a direct adapter that some of these applications have, and some of them have excellent support from like a visualization perspective as well as data ingestion. But the important part is that you get those CloudTrail logs somewhere. It's great to turn it on. It's great to turn it on globally. It's great to archive them in S3. But if you're not looking at them actively and proactively managing certain security-sensitive events, it's a real missed opportunity to make sure that you can sleep at night and that you can move to the cloud comfortably with just some basic alarms set up. So CloudWatch really, really helps with that, especially in terms of cost and in terms of aggregating and filtering down to the vital events. CloudWatch is a metrics and monitoring platform we've had for a very long time for performance and optimization around CPU utilization, memory, network in, network out. You can create filters and metrics on those log messages and those metrics and then create alarms for operations to use. But it's great for CloudTrail integration too. There's a very, very simple integration in the CloudTrail console where you can send a trail directly to CloudWatch logs. And it'll set up a log group, and it'll start sending the logs into CloudWatch immediately. And then you can put metrics and filters on top of that, just like you would in your SIEM. So if you don't have an enterprise SIEM platform, and you want to get some basic alerts and alarms going day one, there's CloudFormation templates that can help you set that up. So let me kind of go over to CloudWatch. So I have my CloudTrail logs going to CloudWatch logs. So CloudWatch logs also has an agent. So if you, instead of syslog or some local agent, you can put an agent on your instances and then forward logs into CloudWatch logs that way too and get them consolidated. But once you have CloudTrail logs into CloudWatch logs, you're able to build log events. So you'll see the same events here that I just showed you, similar log, but now they're going into CloudWatch. So I have my default log group for CloudTrail, and I have 3 filters set up on that log group. So things like when I see the event for list roles, I want to get notification. More importantly, when I see put group policy or put role policy, and there's a bunch of other events that you'll want to monitor for, if I see a metric value of 1, so if I see one of those events, I want to set the alarm for put role policy, which means that here, I would send it to my email, basically SNS topic and then to my email in this case. But you could forward it to a ticketing system, you could forward it to a SIEM. But basically, it's a very simple way for you to make sure security important events are going somewhere proactively early on in the adoption journey. So the next step really is establishing network security, right? You have an existing investment in your data centers. If you have, assuming you have some data centers or colos somewhere, they're pretty capital intensive. You've got multiple different kinds of technologies managing firewalls and load balancers and IDS IPS systems and proxies and things like that in both egress and ingress proxies. All that network security provides a good layer of control and visibility. We don't expect folks to move to the cloud and lose that capability and functionality. Understand, though, this is a global footprint, right? So you want to be able to leverage that global footprint and the resiliency that we provide via regions and availability zones, but it's a different model, slightly different model when it comes to network topology and network segmentation. You have to be able to adapt to the changing nature of where your workload is running. So one of the best things about AWS is that if you use a region, you can have the resiliency of multiple data centers within one region, right? So you have a region like US East, you've got a bunch of availability zones that are presented up to you, and if you architect across those AZs, you're architecting across multiple separate failure modes and multiple separate data centers or clusters of data centers to provide you the resiliency you would normally have to buy through 2 different data centers or 2 different colo agreements or something, right? So that global footprint, right, 12 regions, a bunch new ones planned for 2016, 32 availability zones, all that, when you think about your network topology and your network segmentation and trust zones you've already built, think about how you can scale that, right? Rather than going and buying more firewalls and more hardware and more switches and routers, being able to do that using the VPC APIs and the elasticity of Amazon's regions and availability zones means your topology has to be able to scale too. So this is where VPC comes in. This is a pretty classic AWS slide. So this looks pretty familiar, right? I mean, it's an n-tier architecture. You have an internet gateway, which essentially is your border or your perimeter. In VPC, that's just a construct. That just means you can get out to the internet. You can NAT onto our address space. You also need security groups, and you need a public IP before anything has egress access or ingress access directly from an instance to the internet. But essentially, most people end up having a public ELB, or some kind of an EC2 tier that contains software load balancers. You can even put F5 load balancers on EC2. There's an image for that. There's most of the security appliances that you're already comfortable with, which I'll mention in a minute. Or security partners like Checkpoint, Barracuda, Alert Logic, Cisco, F5, all have AMIs or Amazon Machine Images that run in EC2 that you can put instead of that elastic load balancer layer if you want the familiarity of the appliances that you already have. Things like web application firewalls in place of load balancers from Imperva or Barracuda or Alert, they all work in that sort of perimeter tier, the same way that you could use elastic load balancer as well. But for the most part, this is how modern data centers for web-facing applications are designed. You have a public load balancing tier that hides the auto-scaling or the web tier. In this case, it's an auto-scaling web tier across 2 different availability zones. And then it points to another load balancer down the chain that then points to the application tier. In this case, it's an auto-scaling application tier. So you're targeting that application, rather that auto-scaling group and launch configuration, you're targeting that to 2 different availability zones so that if you have the failure of a rack or Godzilla steps on a building of ours or something like that, you're able to tolerate that failure because the workloads will spin up and scale out in the other availability zones. And again, this works across regions too. So you could have a failure mode of an entire region that would be resolved by Route 53, and it would simply point the resource records that are returned back to the users or clients to an entirely different AWS region, and it's all based on global health checks out of Route 53, which would sit above a particular region. And then you have a data tier. In this case, I'm showing RDS, where you have a master and a secondary relational database service that's scaled across those different availability zones. So you see the auto-scaling tiers are represented with the black dotted lines. Almost every enterprise quickly ends up into a hybrid architecture where you have connectivity back into your existing on-premises infrastructure. So you can do that through public internet and have a IPsec VPN connection to a virtual gateway on our side and a customer gateway on your side. Or you can use Direct Connect to get consistent bandwidth and use your MPLS network or your lease lines to go into our Direct Connect partners, and you can get those in small increments by different telco providers, or you can get up to 10 gig increments as you move into Direct Connect, and multiple 10 gig increments in some cases to get very consistent and high bandwidth between your existing data center locations and AWS, which also means you're able to just simply extend your IP address space, right? VPC, you can carve out RFC 1918 space, and most enterprises will use their IP address management system that they have on premises to build and scale their existing global footprint in their own data centers. They'll carve out IP space and summarize that IP space they've carved out for VPC back into their routing infrastructure or the routing topology on premises. So it just becomes an extension of your data center, just like another pod or another rack or another cluster or another data center on your own data network. So very familiar, and you can have the similar end-tier design where you've got DMZs and segmented zones, essentially by trust. A little deeper look at security groups. Again, Andrew will cover this later today a little bit if you go to that talk, but essentially the security groups are represented by the black and red dotted lines that kind of look familiar to the auto-scaling groups you saw before. Slightly different construct. The security groups are a layer 4 stateful inspection firewalling technology. We just call them security groups. They actually are enforced at each instance. So it's represented here as looking more like a layer 3 or like a VLAN or maybe a PVLAN. But it's actually enforced at the instance. Just for logical grouping's sake and for simplicity of management, you can associate multiple instances across that tier, that web tier, that data tier, app tier, with a single security group. They look kind of like this in the console. So in this case, I have a front-end security group that allows in access from the internet. I've got a web front-end that allows access from the ELB tier down to the web tier. And then I have a back-end tier, so for my app tier or my database tier, that will allow connectivity from zones further up the stack. So in this case, I have selected the ELB front end. And so my elastic load balancers, or if you put some other perimeter device out there that creates kind of the network boundary to the internet into your VPC, that ELB front end group might represent and be associated with instances running those particular devices. But essentially, I'm allowing in 80 and 443 typical web property that I allow access from the entire internet. But I don't want to do that for the backends and for the stuff behind it. So if I'm creating, that's essentially the web DMZ, right? Here, I've selected the web front end. So this one, remember, sits behind the load balancer, so it's not facing the internet. There's nothing publicly routable to this web tier. Everything is protected by load balancers that only allow in ports on the web property and provide certificate management with ACM and other things, or Amazon certificate management. This is where the ELBs talk to the actual backend. So I might be hosting an internal web application on 8443 that I'm hiding behind my load balancers. Basically, this just allows you to logically manage. So rather than having complicated firewall rules and having to remember, oh, that particular CIDR block or that IP subnet is the web tier, and this particular IP subnet is the ELB or is the load balancer network. I don't care about that anymore, right? I just know that my load balancer group is associated, or instances are associated with a security group called ELB front end, and I need to allow the instances in that security group to access the web tier. So I'm basically saying the stuff in the ELB, or the load balancer tier, can access the web services running in the web front end group. So, and very limited, very specific. We also have flow logs. So we launched this, I believe, last year in the New York Summit, sometime in July, July 9th, I think, last year. Totally agentless, sits underneath the infrastructure, so it's actually happening in the hypervisor underneath your instance as we're enforcing the security groups, right? So totally agentless, you can do it at the network interface, the whole subnet, or get flow logs for your entire VPC. It's simple to integrate these flow logs into CloudWatch logs, like I showed before for the CloudTrail integration. You can also send these pretty seamlessly into CloudWatch logs and then forward those into Kibana or Elk Stack or Splunk or wherever you want to put them. Even set up metrics and filters, and I'll show a quick example of that. You can alarm on them, right? So looking at your AWS account, and then the interface, the source IP, destination, they're very much like NetFlow with a little bit of additional data because of the account number and the VPC ID. And it tells you basically whether they're rejected or accepted. So I can send these. This is a look at using the Amazon Elasticsearch service. So if you're familiar with the Elk Stack or Elasticsearch Logstash Kibana that most people run on-prem, it's an open source kind of log management, log search platform. We have a managed version of that. It's a whole separate service that you can connect subscriptions from CloudWatch logs. So you go from VPC flow logs to CloudWatch logs directly into an Elk Stack. And you get this really rich user interface and analysis tier where you can start to build dashboards and start to build rules and searches through managed Elasticsearch. Also, we have a huge array of partners that can eat VPC flow logs and create similar dashboards that are more of a managed kind of out-of-the-box offerings. Splunk, Sumo, Loggly, Papertrail, a bunch of folks. So very quick. You can also set up CloudWatch alarms like I showed with CloudTrail, where I was alarming on put policy. I can also set up a CloudWatch alarm for certain kinds of rejected packets. So thinking in terms of the way security groups work, right? If I properly architect them, I should never see a rejected packet internal to my VPC. No one should be, unless I'm scanning something, right? Like as part of the security vulnerability management program. But I would never see rejected packets if my applications are performing properly, right? So from that web tier to my app tier, and my app tier to my database tier, there should be no untrusted connections in that entire ecosystem. All of my security groups are super dialed down. There's not going to be random client connections coming from laptops because I'm automating the build of the environment. Admins aren't logging into these servers. I'm deploying them through auto scaling, so they're going to come and go as the day, as my users ramp up and ramp down through the day. There shouldn't be people logging into those servers from random IPs on my internal network. I shouldn't see rejected packets. So if I want to set up a threshold for rejected packets on internal systems, that's a great pattern, right? You could set up a CloudWatch alarm. In this case, I've got the rejected packets at 100. That's a little high, probably for internal networks, for detecting sort of unwanted scanning or kind of the inklings of a denial of service attack or something at the edge. I might put a slightly higher threshold on something that's facing the internet. But basically, you get an alarm every time there's enough rejected packets, and you start to see some behavior that you might want to take action on from your security operations folks. Implement data protection. This is a really, really big topic, from everything from crypto and key management into backup and resiliency. There's plenty of talks on the rest of the summit today around protecting your data. Heinrich Johansson, one of my peers, is I think speaking with somebody from Capital One on these topics, I believe, in the next session or later today. But understand though, as an introductory topic, thinking about data protection as you start to move into the cloud as part of that prescriptive approach is super important. KMS, Key Management Service, has been around for quite a while. It used to be under the hood and not really a named public service for elastic block store encryption. So when we launched EBS volume encryption, you're able to simply check a box and have encrypted volumes. That was actually KMS under the hood for a long time before we launched it publicly. We launched it publicly, I believe, about a year and a half ago, and there's hundreds of thousands of keys and mass people using it. It basically integrates deeply with most of our services now that store data at rest. So elastic block storage, relational database service, Redshift, S3 has server-side encryption with KMS. CloudTrail can do encryption of logs at rest using a key that you specify. So you have that integration. Definitely from the visibility perspective too. You want to know who's using your keys, where they're being used from, and who has access to them. CloudTrail natively integrates with KMS, so you get that deep integration every time you use a key or when one of our services uses a key on your behalf. There's also an SDK, very rich SDK in most of the frameworks that are out there, Ruby, Java, et cetera, for application encryption. So you can use KMS to actually, as a developer, to do field level encryption within your application and replicate those, the data encryption keys, to be encrypted under customer master keys in different regions. We also offer Cloud HSM. So if you have an existing on-premises architecture, particularly SafeNet Lunas, there's a way for you to have your own Cloud HSM architecture or your own dedicated FIPS 140-2 compliant hardware security module running in the cloud. We'll rack it, stack it, maintain it, RMA it if it breaks, replace it very quickly. You have complete and total control. There's the root of trust. We have no access to anything in any part of this service. We don't upgrade the device without your involvement. We don't set up the logging. We don't set up the authentication or certificates to the device. We have no access to the cryptographic partitions within Cloud HSM. So it's great for hybrid workloads. It's great if you have a contractual requirement or something to maintain the absolute ownership of your keys. Different scaling requirements for both, different cost factors for both, and kind of different use cases for both. But make sure you're aware that all those things exist. So optimizing change management. And for enterprises, this is critically important if you're at a large company or one that really manages risk. I think it's important for everyone. Whether you're an individual developer, being able to roll things back when you break them. And being able to break stuff's important, right? I mean, you're not learning if you're not breaking stuff, right? So being able to, it goes back to moving fast, right? If you can move fast and make very small incremental changes and make a lot of them, you can move fast. What happens in a lot of companies is they do a quarterly release, or they'll do a very high stakes release where there's so many changes because you've got a project manager now, and you've got budget now, and you've got a change window, so you're going to throw everything into that change window, right? That creates a lot of risk. And that's kind of the benefit of DevOps, is your continuous integration, your continuous deployment, your very high iterative changes, your small batch changes become much faster, right? And lower risk because you're making changes more frequently. The important part, though, is that you see what those changes are. So just like committing to Git or to a source code repository, and you do lots of commits, and you can easily roll back to a different version, now you can do that for your entire infrastructure, right? Not just code. So things like config, where you're recording continuous changes all the time, and config rules allow you to have visibility in a time series way of all the changes that are being made to your infrastructure, be able to archive and compare those changes, and be able to have additional workflow. So quick VPC example, this is a VPC that I built. It's got standard tiers, public, private, etc. So if I change that, config gives me a time series view of all the changes I've ever made. So you'll see I made 6 changes on the 17th of October, 5 or 6 changes on the 18th of October, and it'll give you fine-grained fidelity into what those changes were. Config rules, you can pretty much do anything with config rules. Anything that's covered by config rules, EC2, IAM, and CloudTrail today, future services in the future, or additional services in the future, all those every change that's made, you can pass into a Lambda function through config rules, essentially, and do arbitrary things on those changes. But there's a bunch of config rules that are out of the box. An easy one is tenancy enforcement, for example. So if you want to make sure that certain workloads or certain data classifications are running in dedicated tenancy, you can create a rule for that. So you see I have one that's actually compliant, and it'll tell you that's what's not compliant, and you can go right to the config timeline on the right there and see what instance actually was changed. So someone attached or created a new instance on February the 8th that wasn't dedicated tenancy, it failed the rule check. So I get that time series view and the integration between the two. Bunch of partners in this space, great place for partner ecosystem to give better visibility and IT service management on top of config. Infrastructure as code, so CloudFormation, very important. It's just simply a templating architecture. If you've never seen one, it looks like this. Just a JSON template that defines your entire architecture. So in this case, I'm defining a bunch of alerts for CloudWatch. So anytime somebody deletes a hosted zone in Route 53, changes a CloudTrail configuration, or in this case, changes IAM policies, I've added a few of these. I can templatize these. It sets rules and filters. You're expressing exactly what you want the metric to be. Same things I showed in the console for CloudWatch, or CloudWatch metrics and filters. You can express programmatically in a JSON template, execute that through CloudFormation, and have it executed for you. Obviously, you want to check this into source code, and as you revise these templates and iterate very small changes, you're checking them all in. We launched this thing that I think is one of the coolest things. It's like the bacon or the beer of IT, perhaps. That we launched, I think it was just late last month, and kind of a quiet launch, but these things called change sets. And they allow you to basically roll out the change or preview the change before you actually execute it, which config tells you things, and you can have rules that roll things back, but that's after you've made the change that was authorized. A change set takes a CloudFormation template, diffs it, and then tells you what's going to change. So in this case, I'm changing the CloudFormation template I just showed, where I've got alarms set up for Route 53 and for CloudTrail. In this case, I'm adding some changes to monitor for IAM changes as well. And then let's say, so now I have a change set, and in this case, I'm going to name it, change set date today and 1234, which might be a ticket or a change request ID in your change system. And then, let's say I didn't want to do that, or I want to change it again. I'm going to go delete my CloudTrail alarms. That would be an awful idea to change, but now I know that it's going to change, and I can actually limit who can do this too. I can set permissions on who can execute a change set. So I can have someone submit the change and then have somebody else execute the change through permissioning, and only allow certain people to execute the change set, which is pretty sweet. And you get to preview exactly what's changing. So let's say you want to automate security functions. All of these API calls are great, and you can make everything through the console, but again, at scale, you're going to be automating things. Really, feel pretty strongly about this. Security architecture, maybe in a prior world existed as a separate function. The outputs and the thought of the security architecture function often went into position papers, risk assessments, architecture diagrams. They used UI-dependent technologies, and the audit and assurance of their architectures was done as kind of a separate function. The way that's already gone, and I think the ship has sailed on this one, or quickly sailing, is that it's now, security architecture gets to be part of the maker team now, right? If architecture is a separate function, you get to start early. You can still, as an architect, instead of just doing a diagram or a document, submit that into source code, right? Write your position paper in Markdown and check it into Git or check it into the source code repository like code commit, right? Now your artifact as an architect, your opinion paper, your diagram, your sequence model, whatever, becomes part of the architecture that lives on. And I think it's great. It's a great way for architects to be part of the maker team again. And then you deploy that through something like Jenkins or Code Pipeline, and now your solution architecture becomes part of the living practice. So with the remaining time, I'll try to demo something in a sec here, but I do want to point out the marketplace, that pretty much every security vendor that you might be comfortable with has a presence on EC2 as a marketplace image, or they have a SaaS offering that's either running on AWS or running as a SaaS offering in the cloud. So being able to bring the solutions you're familiar with as a transition to the cloud and to be able, they have great features. I mean, there's some very, very rich partnerships with some of these security vendors, everything from infrastructure security to data protection to logging and monitoring. So being able to take your existing skill sets and the teams that you have on premises that have invested in these technologies, you've got great relationships with the solution architects on those vendors, you have long-term contracts that may have really discounted pricing for some of these features that you need to manage security and build your compliance program. Great partners, so take a look. Really, go get started on this prescriptive approach, right? I mean, really starting at the top left and moving to the bottom right, and then continuing to iterate on the automation is absolutely critical to being able to manage and adopt very quickly. So thank you. I'll take Q&A. I'll also do a quick demo while people are filtering out to other sessions if you want. This is a quick demo of building an AMI, if you want to watch in the sense of time. So essentially, there's this thing called Packer, right, where you can specify what you want to build into an image. So if you have an Amazon machine image and you want to keep it patched all the time and have people start using the patched image every time they launch a new instance, you can specify that in a text file and everything you want to go into the image. So in this case, I want to install all my updates, and because of the application I'm building, I want certain packages installed, right? So I basically check that into source code, use something like Jenkins to pull that repo down. And then I have a build history of every time I've run the task, which gives me pretty much the full console output of everything that happened when I built the image, right? All the packages installed, all the updates, everything that ran, and it builds me a new AMI at the end, and I've got all the logs, right? So just a simple thing like building a server image can be completely automated. So thanks. I can walk somebody through it or take Q&A on the side. So thanks.